Welcome to the third video of Caramo's Machine Learning Toolkit, featuring Experiment 3. Open the app, and once it's ready, navigate to Experiment 3, Statistical Summarization and Pivot Tables to begin. Under the Introduction tab, you'll find the aim of the experiment. This is an intermediate-level activity designed to strengthen your skills in understanding and summarizing data, showing why statistical summaries and pivot tables are essential for uncovering patterns, spotting trends, and preparing data sets for deeper machine learning analysis. Let's move forward. Open the Pivot Table tab to create a table that groups and summarizes data, helping you quickly compare values and identify patterns. You can see two panels. The main panel will have your pivot table, and in the left is your control panel. The first step is to import data into the experiment. You can either use the selected dataset from the previous experiment by choosing Global Data, or load a completely new file by selecting Load New Data. After importing the dataset, you can view the total number of data points and features displayed in the top right corner, and explore the complete list of features conveniently shown in the control panel for easy selection and analysis. Now, choose the required parameters, index, optional columns, values, and an aggregation function as shown. Then click Create Pivot Table to generate your first pivot table, or simply use Auto-Generate First Pivot for a quick automatic setup. A pivot table is a powerful technique for condensing and analyzing large datasets. It organizes information by grouping data into chosen categories and applying calculations such as sums, averages, or counts, allowing you to uncover patterns, trends, and relationships that may be hidden in raw data and gain clearer insights for interpretation or decision-making. You can now see your pivot table, showing a clear summary of all the features and details you selected. Now, let's move on to the next part of the experiment, which is the feature statistics analysis. On the screen, you can see that for every selected feature, the tool automatically generates a distribution plot along with key statistical values. This includes the count of observations, mean, median, quartiles, standard deviation, minimum and maximum values, and other important metrics. This is useful because it gives you a quick understanding of how each feature behaves before you use it for modeling. With these statistics, you can easily identify trends, spot anomalies, and decide whether any pre-processing or cleaning is needed. You also have the option to split the histogram using any categorical feature in your dataset. This is useful because it allows you to compare the distribution of a numerical feature across different groups or categories. For example, if your dataset has categories like disk type or input PWM, splitting the histogram lets you see how each group behaves individually. This helps you identify patterns, variations, or inconsistencies that may not be visible when viewing the combined distribution. After you have analyzed the data thoroughly, you can also export the analysis report from the experiment and save it for future reference. After saving the file, you have successfully completed the analysis and finished Experiment 3. But before we move ahead, let's take a moment to open and review the report we just generated. This file gives a quick summary of each feature's statistical details. Experiment 3 is now successfully completed. In the next session, we'll uncover even more tools for data understanding.